Hey guys, today is Monday, August 15th. Okay, so today in math, we're going to be working on, we're going to kind of work on the iReady. We're going to work on that for a little while. Next, we will work on greatest common factor, at least common multiple. Here's some examples that we're going to be, how the process goes if you're unfamiliar. Uh, so, greatest common factor, we picked a problem here, 35 and 20. Okay, so we're looking for the greatest common factor. So what I advise, let's rewrite this a little bit, scoot over a little bit. 35 and 20. Okay, so what I advise is starting at the ends. Now, there's various ways to do this, but to me, the most efficient, especially for a sixth grader, is doing it this way. I would say 1 times what is 35, and we know that it's 35. Okay, now you got to say, well, 2 times what equal 35 evenly. Okay, well, if you don't know, you would go ahead and do like a division problem. Okay, or say your multiples of 2. Either way, we know that this is an even number, this is an odd number, so we know it won't go in there. Okay, so there's really no need of doing that. So 2 won't go in there. 3, we go through the same process. 3, the closest thing is 11 and 12, and so that's 33, and then 36, so that won't go. Will 4 go into it? 4, 8, 12, 16, 20, 24, 28, 32, 36. 4 won't go either. So 5 will. So 5 times what is 35? So 7. So you say, will 6 go into it? It will not, because 6 times 5 is 30, 6 times 6 is 36. So it kind of misses that. Okay, so now, same process with 20. Okay, we're not going as in depth, but we understand. 22, I know 2 will go into it. 2 times 10. 3 won't go into it. 4 will go into it. 4 times 5. And then so we're right there, right next to each other numbers. So we know that the greatest common factor of 35 and 20 is 5. Okay? All right, now we have least common multiples. Okay? Same kind of we're going to do these at the same time. Okay? So basically what a multiple is, it's like a number times 1, a number times 2, a number times 3, so on and so forth. So if you're just kind of learning this stuff, this is kind of be my recommendation of go ahead and putting these up there. And the only reason I went to 5 is kind of like just like a rule of thumb that I do. You can go more, you can go less. It doesn't really matter, but it gives me a starting point, okay? So I know 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. 2 times 5 is 10. Okay, same process with 8. 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. 8 times 4 is 32. 8 times 5 is 40. Okay, so it's the least number, the smallest number that's got to be common to both of them, so it's got to be in both of them, okay? And we see the smallest number is, it's in both of them, is 8. So least common multiple is 8 here. Greatest common factor is 5 there. Okay? Hope that makes sense. Now, that's kind of the gist of what we're doing there today. So we will be working some problems here. Maybe you see this right here. Hope you can see this. So problem number 1, it says Sarah has 16 red flowers. Let's go ahead and write that down here while we're doing this. 16 red flowers. She has 24 yellow flowers. She wants to make bouquets with the same number of each flower in each bouquet. What is the greatest number of bouquets she can make? Okay, so when it says greatest number, we know that's the greatest common factor, okay? So we're going to be looking at the greatest common factor of 16 and 24. Okay, so we know factors of 16 are 1, 16, 2, 8, 3 won't go, and it's 4 times 4. 24, 1, 24, 2, 12, 3 times 8, 4 times 6, 5 won't go. Okay, so we can have the biggest number that's common to both of them. Okay, the greatest factors in both of them. So the 1s, 2s, there's no 3s. You got 4, you got 8. Okay, So 8 is the greatest common factor, okay? So 8 bouquets. 8 bouquets. So that's number 1. Any questions, let me know, guys.